Hey, Killian here. And let me state the obvious here. Forever is a very long time. Let me put it into perspective for you. Think about how long the universe has existed, its past and its present. Now, think about how long the universe will continue to exist for, its future. That is forever. It's a pretty long time, longer than your brain could even fathom. But exactly how long is forever? Well, that's easy. It depends how much space you put between the letters. Thank you. I pride myself on my comedic genius. But seriously, if you came up to me on the street and asked me, Killian, how long is forever? My answer would be, it depends. That may seem like a cop-out answer, but it really is true. The length of forever is relative. That means that the length of forever depends on what exactly you are talking about. Let me give you an example. Let's say there was a woman. We'll call her Sandra. Sandra was born in 1900 and lived for 100 years. That means forever, relative to Sandra, is 100 years long. Forever, relative to me, is 17.3 blah years long, as of recording this video. Great, we now understand forever, relative to people, animals, or objects. But what about something bigger? Say, the Earth. How long is forever, relative to the Earth? This is where things start to get complicated. The Earth has been estimated to be 4.54 billion years old, with about a 2% margin for error. I'd say that's fairly accurate. But what about the future of the Earth? Well, as you can probably imagine, predicting the demise of our Earth is pretty difficult. Shaking the magic 8-ball won't cut it. There are many different threats to our world which could definitely spell the end. But the thing is that they can end life on Earth, not the Earth itself, which will continue on existing in our solar system. There's a big difference. Because of this, we have to split the Earth's forever into two categories: life on Earth and the physical Earth. We'll calculate both separately, though their timelines are rather similar because of one massive factor: human control. While the likes of nuclear war, bioengineered pandemics, nanotechnology, artificial intelligence, and so on do pose a threat to the world, there's no guarantee these events even happen. We could stop developing artificial intelligence tomorrow, and all of a sudden that threat is crossed off our list. So then, what is almost guaranteed to end the world when the time comes? The sun. The ball of gas, which is the key to our survival on this planet, is what will eventually destroy the Earth. It's pretty ironic when you think about it. The sun, as we know, is a star, and when stars die, they like to go out with a bang. One thing worth noting before we move on is that the death of the sun is only guaranteed to end life on Earth. While it is pretty unlikely, the physical Earth could definitely survive the sun's death. The expansion rate of a star during its death can range from anywhere between 100 times and 1000 times its original size. But we're going to assume the Earth won't survive this, because otherwise I wouldn't really have anything to fill the next several minutes with. After about 10 billion years of a blissful life of burning hydrogen into helium, our sun will run out of hydrogen. The issue is that the sun cannot burn the leftover helium, and this causes gravitational forces to take over. Eventually, these forces will compress the center of the sun so much that it begins to burn hydrogen in a small shell around the dead core. The compression in the center of the star allows the outer regions of the star to expand outwards. Because the star is expanded, it cools down as there is more volume for the same amount of heat to fill, turning the star from white hot to red hot. The sun will likely continue to expand until it reaches the current orbit of Mars, giving the Earth no chance. As we mentioned before, it's tricky to predict the expansion rate the sun will experience when it dies, but we'll take the most common 300 times rate as the figure, which will completely destroy the Earth. So we know the Earth will be destroyed. But at what exact point in time will the sun have expanded so much that the Earth is no more? This is where things start to get complicated. We'll have to go back to our two subcategories from before: life on Earth and the physical Earth. Let's start with the physical Earth. To get the answer we're looking for, we have to look at the life cycle of the sun. The sun was born about 4.57 billion years ago, and has been burning hydrogen ever since. We talked earlier about the sun running out of hydrogen to burn, and that is estimated to happen in about 5.4 billion years. Next, we have a few calculations. I'll leave a link to the Python file with these calculations in the description so you can check them out for yourself. Before you say, yes, I know it's overcomplicated. That's what makes it fun. We need a few numbers before we get calculating. These are the distance from the Sun to the Earth, the radius of the Sun, the radius of a red giant, and the lifespan of a red giant. A quick Google search will tell you that the distance from the Sun to the Earth is 149.6 million kilometers, and that the radius in the Sun is 700,000 kilometers. The radius of a red giant is 300 times the size of the original star, as we mentioned before, which equates to 210 million kilometers. The lifespan of a red giant is trickier, but has been estimated to be about 2.2 billion years. So now, the calculations. What we are trying to calculate is the years the physical planet of Earth has left, so we will set that as x. The easiest way to get this is using ratios and cross multiplication, so we set up the formula like this. The distance from the Sun to the Earth over the radius of a red giant is equal to x over the lifespan of a red giant. A bit of cross multiplication gets you the answer of 1,567,238,095 years. But we're not quite finished yet. That's how long into the red giant phase the Earth will perish. But we still have to add on the remainder of the current Sun's life. That number plus 5.4 billion, how much longer the Earth will live for, gets you the grand answer of 6,967,238,095 years until the physical Earth is destroyed. So, moving on to life on Earth. The nice thing is we can reuse a lot of what we used in our last calculation. To calculate how long life on Earth has, we need to look at the habitable zone in our solar system. The edge of the habitable zone lies 142 million kilometers away from the Sun. As the Sun expands in its red giant phase, the habitable zone will be pushed backwards, eventually taking the Earth out of it. But exactly when will this happen? We'll set x as years left for life on Earth once more, and the formula for this calculation looks a little bit like this. The radius of the Sun when the Earth is pushed out of the habitable zone over x is equal to the radius of a red giant over the lifespan of a red giant. Cross multiply and whatever and you get 86,952,380 years. Add that on to the trusty 5.4 billion years and we get 5,486,952,380 years until life on Earth is gone. But there's a bit of an issue here. Something we didn't mention before. As the Sun burns hydrogen, its luminosity increases at a rate of 1% every 100 million years. It doesn't seem like much, but the Sun is already extremely bright at a negative 26.74 apparent magnitude. Because of this, in as little as 1 billion years, the Earth will become uninhabitable for humans. This is because the increased luminosity will also increase heat energy, which will be absorbed by the Earth's atmosphere. This will in turn trigger a greenhouse effect here on Earth, similar to what we see on Venus. This will trap heat inside the atmosphere and cook us all alive. So, forever in terms of life on Earth is about 4.5 billion years long, and forever in terms of the physical Earth is about 11,537,238,095 years long, once we add on the past.
Wow!
So that's it for this video. If you enjoyed, be sure to like and subscribe with post notifications on so you don't miss an upload. If you'd like to check me out on social media, my Instagram and Twitter is linked in the description. Please do, I'm desperate for attention. Anyway, that's it for today's video. See you later and thanks for watching.